Okay, now we start the mock exam by solving the extended question number 15, part A. Describe the Doppler effect. Doppler effect is change in wave frequency during the relative motion between a wave source and observer. Now, part B. We read the question, be careful. Okay, here. A car travels with constant velocity along a straight route. The car horn with frequency. So this is Fs, the frequency of source. It's 400 hertz. It's sounded continuously. A stationary observer, of course, in all our syllabus, the observer is stationary. On the road side, hears the sound from the horn at frequency. So this is the frequency detected by observer, F naught. So F naught equal 360 hertz. The speed of sound, so this is V, 340 meter per second. Determine the magnitude V and direction of velocity of the car relative to observer. Now we need Vs. Direction, it means the car is moving away or moving towards the observer. We note that from the given, the frequency detected by observer is less than the frequency of the source. So we write as F naught is less than Fs, so the car moving away from the observer. So the car moving away from observer. So this is the direction, the car moving away. As the car moving away, then it's plus. So the formula that we can use, F naught equals Fs V over V plus Vs. Now we substitute. So from this relation, F naught is given 360. Fs also is given 400. Multiply V, the speed of sound in air, 340, over 340 plus Vs. Now we need to calculate Vs. How to calculate Vs? We do cross multiplication. Then this is over 1. And then we multiply this by this and this by this. Cross multiplication. Now, 400 multiply 340. Or I can do it step by step. 1 multiply 400 multiply 340 equals 360, open bracket, 340 plus Vs. We divide both sides by 360 to simplify. So we cancel this, divide by 360, divide by 360 to cancel this with this. Then the answer is, solve with me, please, to don't reduce the time, please, to don't lose the time. 400 multiplied 340 divided by 360. So the answer is It is 377.78 equals 340 plus Vs. 340 go to the other side, then we can get Vs minus 340. Then the answer is 37.8. 37.8 meter per second. So this is the answer of this question. Next question. Read the question, be careful, and try to solve the first. Now I read with you the question. The following figure shows the variation with time t of displacement x. So it is displacement time. Remember, in waves, we have displacement time. So this is displacement, or we can say it's y, it's better. Okay, so it is displacement time. And also we have another graph, displacement, sorry, the same stick. Okay, displacement distance. So this is y, and this is x. If we have the graph like this, or like this, now, from displacement time, we can deduce the time period. So this is the time period. Displacement distance, we can deduce what? The amplitude. In both, we can deduce the wavelength. In both, we can deduce also the amplitude. So this is the amplitude. Then displacement time. The time of one complete wave is the time period. Displacement distance, the length of one wave is the wavelength lambda. So this is displacement time. Then we can deduce the time period. Two progressive waves, B and Q, okay, passing the same point. Calculate the period of the waves. Now, we can take one complete wave. We can take this wave. You can see here. So this is one complete wave. Okay, so this is one complete wave. So this is the time period. So the time period is 0.6 seconds. So this is the time period. So the time period denoted by t, 0.6 second, 0.6 second. He said calculate the time period. So the time period from the graph equals 0.6 second. This is number one. Now, second, determine the phase difference between the two waves. Now, the phase difference when they are sine. So the first wave starts as sine from this point, and the second wave starts from this point as sine. Then this is the phase difference. So this is the phase difference. So this one is the phase difference. Now, we have a formula for the phase difference if it's time. So the phase difference in case of time, the phase difference equals the t over t times 2 pi. In case of lambda, the phase difference equals the d over lambda multiply 2 pi. Then the phase difference equals the t small, the difference in time between the two waves, over the time period multiply 2 pi. Now, from the graph, t small is 0.2. So 0.2 over t capital is the time period 0.6. Multiply 2 pi. So the answer is 2/3 pi. So this is the phase difference. Next question.
أستاذ
Yes.
أنا عندي سؤال.
Yes, Sam, تفضل.
كيف ترى مطلع التي سمول؟
From the graph, this is t small. This is t small. This. It is the difference in time between the two waves. So this is t small. It is 0.2 from the graph.
تم.
Now, calculate the ratio of intensity of Q over intensity of B. We know that the intensity proportional to amplitude squared. Then the intensity of Q over the intensity of B equals the amplitude of Q squared over the amplitude of B squared. Now, what is the amplitude of Q? Let us see the amplitude of Q from this figure here. So the amplitude, the green one is B. So this is B. The amplitude of B is 3 millimeter. The amplitude of Q, this is Q. It's 2 millimeter. Then the phase difference. So the phase difference equals the amplitude of Q. We said it's 2 millimeter, but the unit is not important because both of them in the same millimeter. Then it's 2. This is the amplitude of Q squared over amplitude of B, 3 squared. 2 squared is 4, 3 squared is 9. That's it. Now, next question or next part. The two waves superpose as they pass the same point. Use the figure to determine the resultant displacement at t equals 0.45 seconds. Now we go to the graph and determine the point 0.45. Now, this point is 0.5, then 0.45 at the middle here. Okay, now we draw perpendicular. So this is the perpendicular at this point. This 0.45 seconds. And then we find the amplitude, which is 1 millimeter. And down, the other one, it's -3 millimeter. Then the phase difference is 1 minus 3. Up is positive, down is negative. Then it's 1 minus 3, it's -2 millimeter. So this is the answer of question number 16. Now, next question. Okay. I give you time to read it, and then we solve. Try to understand the question and try to solve it first. Okay. Now, let us read the question together. Laser diffraction grating, a laser and a diffraction grating and a screen are set up as shown. The laser emits monochromatic light. Monochromatic, it means that has one color or one wavelength. The diagram below shows the position of central dot O. So this is the central dot. This is the central maximum O. The next bright. So this is the first bright. Okay. So this is the next bright. It means this is the first bright. First, it means n equals 1. Diffraction grating has 450 lines per meter. First, we calculate D. So D, we divide 1 millimeter over 450 lines. The answer is, okay, 2.22 multiplied by 10 to the power negative 6 meter, because we convert millimeter to meter, multiply 10 power negative 6. So this is D. He said determine the wavelength of light. The formula that we can use is D sine theta equals n lambda. Then lambda equals D sine theta over n. D already is given. N is 1. Now we need to calculate theta. This is the angle theta. Angle of first order. Here we have the opposite and the adjacent. Then we can calculate tan. So we calculate tan theta from the triangle. Tan theta equals the opposite 0.5 millimeter over the adjacent 1.690. Then we can calculate theta by using the calculator, shift tan answer. First check its degree. Now, fraction 0.5 divided by 1.69. I advise you to solve with me. Equal, shift tan answer. It is 16.5 degrees. So it is 16.5 degrees. N equals 1, so we can calculate lambda. So lambda equals D. D is 2.22 times 10 to the power negative 6 multiply sine theta, sine 16.5 degrees over n over 1. Already in my calculator 16.4, we find the sine answer, and then we multiply by 2.22 multiply 10 to the power negative 6 divided by 1. It is the same. Now in scientific, shift mode 7.3. So the answer is 6.3 multiply 10 to the power -7 meter. Check your answer with me, please. Okay? Now, next part. Explain why series of bright dots is seen on the screen. Series of bright. Now I tell you the answer and write with me, please answer. Waves from diffraction, waves from different slits meet and superpose. Bright dots are waves in phase because constructive interference. I will write this for you to be easier. So the answer is waves from different slits meet and superpose superpose bright dots are waves in phase because constructive interference. Constructive. Okay, now, next question. The laser is replaced by source producing parallel beam of bright white light. Suggest what would now be observed on the screen. The central would be white and the spectra seen either side of O. So we write white dot at the center O. And spectra means rainbow. The spectra seen either side of O. So around O we will get rainbow. Now, next question. Okay, now next. Okay, next question. Read the question, please, and try to solve with me. In experiment, okay, to determine the speed of sound in air, when the length of the air column was I or L, this is I, it is the length, so this is the length L, I. A stationary wave with one node, this is one node, and one antinode, here, this is antinode, was produced as shown. Explain how a stationary wave was formed in this experiment. So the wave reflected by the water surface, and then this is the incident wave, and this is the reflected wave, are interfere to produce the stationary wave. So I write this for you. Waves have been reflected by the water surface. Incident wave and reflected wave interfere. Incident wave and reflected wave interfere. Two for the stationary wave. Now, next question. A sound was heard when I equals, I is the length, then this is the length of the column air, 19.3 centimeter. We convert to meter, divide by 100, so it is 0.193 meter. Determine the value of the speed of sound in air, and we have here the frequency. The frequency equals 440 hertz. Now, this is a quarter lambda, because from node to antinode, it's a quarter lambda. Then L equals 1/4 lambda. Then we can calculate lambda. So lambda equals 4 multiply L. 4 multiply L is 0.193. So lambda equals 0.772 meter. Now we can calculate V from the formula V equals lambda multiply F. Lambda is 0.772 multiply the frequency 440. The answer is 339.7, and the unit is meter per second.
أستاذ
Yes.
يصير لو صح تعيد السؤال مرة ثانية.
مرة ثانية. I said from the beginning or from B? Part B?
Part B.
Part B. Here we have the length L. I stand for L. This is I. Okay? So this is L. So the given is L. 19.3 centimeter. We convert to meter, divide by 100, 0.93. And we have the frequency 440. We need the speed. First, we calculate lambda. In case of air or pipe, the distance between node and antinode is quarter lambda, because the distance between node and node is like this. Node and node, it's a half lambda. Then between node and antinode is quarter lambda. So quarter lambda equals L in that question, in that part. So quarter lambda, it is the distance between node and antinode. So L equals a quarter lambda. Then lambda equals 4L. L is given, we multiply by 4. So this is lambda. We have the frequency, then we use the formula V equals lambda F to get the speed. Okay, now.
تم أستاذ.
Next question. The antinode, the point is down, is slightly further from the water than the end of glass tube. يعني هي بعيدة. Explain how this would affect the accuracy of your calculated value for the speed. دي بتأثر ازاي على accuracy of the speed. The wavelength would be longer, لأن اللامدا هتزيد. This would cause the value of speed to be higher than the calculated. V, it will be more, which is less accurate. Again, wavelength would be longer. This cause the wave speed, this cause the value of speed, the value of speed is higher, أكبر, higher than calculated value. Which is less accurate. Which is less accurate. So the calculation is less accurate because this reason. Now, next question. Okay, if it is definition or something, we can see it oral. State the principle of superposition when two or more waves meet at a point. The resultant displacement is the sum of displacements of the individual waves. I repeat again. Principle of superposition. When two or more waves meet at a point, the resultant displacement is the sum of displacements of the individual waves. Now, let us solve next question. Now, read the question and try to solve it first. Now, let us read the question. Circular water waves are produced by vibrating diapers at points B and Q. Then we have source of wave at B, source of wave at Q. Illustrated in the figure. Okay, now. Okay. The waves from B alone have the same amplitude at point R as the waves from Q alone. Distance BR equals 44 centimeter and the distance QR 29 centimeter. The diapers vibrate in phase. Okay. So this is important word. With a period of, then we have the time period. So this is the time period. 1.5 seconds. To produce waves of speed, we have here the speed of wave, 4 centimeter per second. Calculate the wave length of the waves. Now, V equals lambda multiply F, or V equals lambda over time period. Then we can use this formula, V equals, but now we need lambda, sorry. Then we can rearrange this to get lambda. We can use this one here, like this. Okay. V equals the lambda multiplied T. Then lambda equals V multiply the time period. Now we can calculate lambda. V is 4 centimeter. T is 1.5. 4 times 1.5 equals 6. The unit is centimeter. So this is lambda. Calculate the path difference at the point R. Give your answer in terms of lambda. Now, what is the path difference? Okay, here, path difference equals 44 minus 29. Now, 44 minus 29 equals, okay, shift mode, okay, equals 15 centimeter. Now, 15 centimeter, if we divide 15 by 6, so 15 divided by 6, 6 is the length of one lambda. It is 2.5. So we write here 15 centimeter is 2.5 lambda. So this is the path difference in terms of lambda. Because it's a 2.5, then it is destructive interference. Describe the motion, if any, of the water particles at R. Because it is destructive interference and they are identical source, then no movement will be plain. Waves have path difference, path difference 2.5 lambda. Destructive interference. So the particles are at rest. So the particles at rest. At rest or no motion. So this is the answer of this part. Now, next part. Okay, read the question, be careful, and try to understand it. Beam of vertical polarized light is incident normally on a polarizing filter, as shown in the figure. The transmission axis of the filter is initially vertical. Vertical, it means the maximum, because theta equals 0. The filter is then rotated through an angle of 360. It will be rotate 360 degrees. While the plane of the filter remains perpendicular to them. On the following figure, sketch the graph to show the variation of intensity. We need I. What is the relation between intensity and angle? That I equals I naught cosine squared theta. Okay, now because it's a cosine squared, so it will not be positive, it will not be negative because cosine squared. Okay, now what is the answer here? What is the question? Okay, on the following figure, sketch a graph to show the variation of intensity of the light in the transmitted beam with angle through which the transmission axis rotated. At 0, it is maximum. At 90, it is 0. At 180 is maximum. At 270 is 0. At 360 is maximum. Then the graph takes this. It is sine graph. Why all? Up to x-axis because it's a cosine squared. So this is the graph. Okay. Now, next part. The intensity of the light beam. Now we write the given. The intensity is, so this is I is given. The intensity of the light in incident beam when the transmission axis vertical. Then this is I naught, the initial intensity, the maximum value. Because we said when theta is vertical, filter is at theta is vertical. Vertical, so theta equals 0. The light intensity transmitted is 4.2. So this is I. 4.2. Remember the unit? It is watt per meter squared, watt per meter squared. Calculate the angle theta. The formula that we can use is I equals I naught cosine squared theta. Then from this, we can say cosine squared theta equals I over I naught. Now we can calculate cosine squared and then cosine. So cosine squared theta, I is 4.2 divided by I naught 7.6. Then we can get this answer. Fraction 4.2 divided by 7.6 equals 0.55. Take square root cosine theta equals square root of the answer, 0.74. Then we can get theta, shift to cosine or arc cosine, 0.74. So shift cosine answer, theta is 41.97. 41.97 degrees. Next part. This part about Young double slit. An arrangement that uses double slit. Double slit, remember the equation that we can use when we say double slit. So lambda d equals ax. So this is the equation of Young equation. The interference of light from laser as given. Now from the given here, we have the wavelength. So this is a given, light of wavelength. Then we have lambda. Lambda equals the 6.2 multiply 10 to the power -7 meter. Also, this is D, capital, the distance between double slit and the screen, 2.8 meter. An interference pattern of bright fringes and the dark fringes are formed on the screen. Now we have the screen. It is the same like experiment we did in the lab. Now, here you can see here the distance here. So, how many bright here? So it's 1, 2, 3, 4, 5, 6, 7, 8. So this is the distance here. So it's 8x. So from this figure, we can say 8x equals 22 millimeter. Then x equals 22 over 8 millimeter. We convert to meter, multiply by 10 to the power -3. So the answer is 2, I check it, 22 fraction, 22 over 8, multiply 10 to the power of -3. The answer shift mode 7, 3. The answer in scientific 2.75, 2.75 multiply 10 to the power -3 meter. So this is x from the figure. The light waves, now we have given lambda, d, and x. Light waves emerging from the two slits are coherent. State what is meant by coherent. Coherent means two or more waves have a constant phase difference. Two or more waves have constant phase difference. Now, next part. Calculate the separation A. Now, the formula is lambda d equals ax. Then A, rearrange it, so it's lambda d over x. Now, we calculate this. So, the answer is lambda is given, lambda is 6.2, multiply 10 to the power -7, multiply d, it's 2.8 meter, divided by x that we calculated, 2.75, multiply 10 to the power -3. By using a calculator, the answer is 6.3 multiply 10 to the power -4 meter. So this is about young double slit.
طب
Yes.
أنا عندي سؤال.
تفضل.
كيف في الجيفنجز لما طلعنا الإكس من هين جبتها الإيت إكس؟
Good question. This is bright. It's okay. So this is bright. Can you see? It's bright.
Yeah,
And this is bright. Okay, bright, and so on. Bright. It's okay. And this is darkness. It's okay. Plus, right?
Yeah.
Okay. Now, here. Can you see?
نعم.
Now count with me. How many x's? Okay. Here, this is 1x, 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 1x. 1, 2, 3, 4, 5, 6, 7, 8. They are 8x.
تم.
Okay. Let us we go to the next question. Okay, now next question. Answer the following. Derive general expression for the frequency of nth node in a string. Just we add this because we have nth node in pipe. This is in a string. In a string. Okay, now we need to derive the formula. Look. Okay. To derive this formula, we draw here. This is lines like this, 2 lines. And this is the string L. Just we need 3 cases, L. So L is the distance between the 2 points. In the first case, we have, okay, 2 nodes, 1 loop, like this. In the second, we have 2 loops, like this. In the third, we have 3 loops, like this. Now, in the first case, n equals 1. the distance between two successive nodes, this is node, 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 node. The distance between two nodes is half lambda. Then half lambda equals L. Then lambda equals 2L over 1. Then F1 equals V over lambda. V over 2L over 1. So it's 1V over 2L. This is when N equals 1. Now, when N equals 2, 2 loops. 2 times a half lambda equals L. Then lambda equals 2L over 2. Then F2, similar, it's 2V over 2L. When N equals 3, 3 times a half lambda equals L. Then lambda equals 2L over 3. Then F3 equals 3V over 2L. Then generally, Fn equals NV over 2L. This is a drive. Next question. A stretched string PQ of length. Then here we have L. So L equals 1.2 meter. One end of the string is attached to vibration generator and the other is attached to the wall. The vibration generator switched on and the stationary wave is formed on the string. The string shown at one instant of the time. So here, how many, here, this is N, it's okay. So this is the stationary waves. Okay, here. Explain how the stationary wave is formed between the vibration generator and the wave. When it travels along adjustment, I put the battery running out. Explain how a stationary wave is formed between vibration generator and the wave. Yeah, we can say that, but I move it up because we have another. Okay, here. Just I move this up because we have another question down. So I need to put all the questions in the same page. Okay, yes, I hope will be running. Yeah, now explain how the stationary waves. Waves travel along a string and reflect at a fixed point. Incident and reflected wave superpose. So this is the stationary wave. So waves travel along string, and reflect at fixed point, incident and reflected wave superpose. Incident and reflected waves superpose. Now, calculate the speed of progressive waves on the string. Now, how many loops here? You can see here 3. Then, how lambda? So we can say 3 times half lambda equals 1.2. So lambda equals 1.2 divided by 1.5. 1.2 divided by 1.5. So it is 0.8. So lambda is 0.8 meter. Now, here we have the length, خلاص, we got it. So progressive waves. Now let us, we see here we have stretched 1 meter vibration generator. Okay, now what about here? Calculate the speed on the stretched wave. Just I check what are the givens here. Generator as shown here, vibration generator 1.2. The switched on and the stationary wave is formed. The string shown at instant time. This is okay. Calculate the speed of wave on the stretched string. I think here we have here given. Okay, the distance equals. Okay, we need the time actually here. So here the given time here is 0.16, but it is not given in the question. So just I add here the time period. It's not given. It is 0.16 seconds. So the speed of wave equals the lambda over the time period. So lambda equals 0.8. This is not in the given, sorry. So just add this. The time period equals, this is given. Add it to the given. 0.8 divided by 0.16. So the answer is 5 meter per second.
Stop.
This is the time. It's okay. Just we add the time period here. Time period is given, but not written in the question. 0.16 seconds. Yes, Osama.
كيف الويف لينث 0.8
Again, look, from this to this, it's a half lambda. And from this to this, it's a half lambda. And from this to this, it's a half lambda. So this is 1.5 lambda from B to Q. 1.5 lambda equals 1.2, the distance BQ. It means 1.5 lambda equals 1.2. Then lambda equals 1.2 divided by 1.5 equals 0.8. Okay? Now, this part is about the waves. Now, just we take a break about 5 minutes and then return back. Okay, Shabab, ready? Okay,
Yes.
great.
Yes.
Okay. Now we continue the next question. Okay. Now, next question about quantum physics. Read the question, be careful, and then we answer. Ultraviolet light is incident on zinc plate. So here we talk about zinc plate, and ultraviolet. This is given. State what is meant by work function. Minimum energy required to release electrons from surface of metal. Minimum energy required to release electrons from surface of metal. Now let us do the next question. Now read the question, be careful with me, and try to solve. Ultraviolet UV section of electromagnetic spectrum can be split into three parts known as ultraviolet A, ultraviolet B, ultraviolet C. So this is three parts. The range of wavelengths of these parts is given. So this is the wavelength of ultraviolet C. It's from 200 to 180 nanometer. And B, 280 to 320, and A, like this. The minimum de Broglie wavelength, now we have lambda Broglie. So this is lambda Broglie, or lambda de Broglie. It's given 1.5 times 10 to the power negative 9 meter. Deduce whether ultraviolet light incident upon the zinc plate is now which one to get. Now we need to calculate lambda. And then we compare lambda to choose which one. Here we have the work function of the zinc. So this is given. Phi equals 4.3 electron volt. Now, first step, we calculate the energy of incident. From the energy, we can decide. Then we calculate the energy. What is the energy? Which formula for the energy? Kinetic energy maximum. Okay. Kinetic energy maximum equals E minus phi. We need the energy from this formula, rearrange. So the energy equals kinetic energy maximum plus the work function. Now we need to calculate the kinetic energy and the work function. Now, okay, now we need to calculate the kinetic energy. First, we go to lambda de Broglie. Lambda de Broglie equals H over mv. M is the mass of electron, V is the speed. From this, we can rearrange it. So mv equals H over lambda divided by M. Then V equals H over lambda multiply M. Now we substitute. H is Planck constant, 6.63 times 10 to the power negative 34. Lambda is given, lambda Broglie 1.5, multiply 10 to the power negative 9. M is the mass of electron, 9.11 times 10 power negative 31. Now we calculate V by using the calculator. Calculate with me, please. So the answer is 4.8. Okay, so the answer is 4.85 multiply 10 to the power 5 meter per second. From this, we can calculate kinetic energy equals half mv squared. So it's a half multiply 9.11 times 10 power negative 31 multiply v squared, which is 4.85 times 10 power 5 squared. So squaring this answer, multiply by 0.5, multiply 9.11, multiply 10 to the power negative 31. So the answer is 1.07. So the kinetic energy equals 1.07 multiply 10 to the power negative 19 joule. And phi is the work function. It's a given 4.3, but we convert it to joule. So it's 4.3 electron volt. To convert it to joule, 4.3 times 1.6 times 10 power negative 19. 4.3 multiply 1.6 multiply 10 to the power negative 19, 6.88 times 10 to the power negative 19 joule. Now we can calculate the energy. So we calculate the energy. So the energy equals the kinetic energy maximum plus L5. Kinetic energy is 1.07 multiply 10 power negative 19 plus phi 6.88 multiply 10 power negative 19. So this answer plus 1.07 multiply 10 to the power negative 19. So the answer is 7.6, 7.95, 7.95 times 10 to the power negative 19 joule. The energy equals hc over lambda. Then we can calculate lambda. Lambda is the required. Take care. Lambda, it is not de Broglie lambda. This is lambda of incident wave. Then from this, we can rearrange. So lambda equals hc over E. H is 6.63 times 10 power negative 34 multiply C, speed of light, 3 times 10 power 8 divided by E, 7.95 times 10 power negative 19. So the answer here, 6.63 multiply 10 to the power negative 34 multiply 3 multiply 10 to the power of 8 divided by the answer. It's 2.5 times 10 power negative 7 meter. We need to convert it to nanometer, multiply by 10 power 9. So to convert to nanometer, multiply 10 power 9. Multiply 10 to the power of 9. So the answer is 2.5 or 250. Now shift mode 8 to be scientific. So it's 250.18 or 0.2 nanometer. Then we can decide which one 250. It is ultraviolet. Which one? Yes, 250. It's here. This is 250 here. So it's UVC or ultraviolet C. So the answer is, so it's ultraviolet part C. This is a long question. It has many calculations. Now, next part of this question, still we have another part of this question. A student used zinc plate and the ultraviolet light of different frequencies in an experiment. The student graph of maximum kinetic energy of the released electron against the frequency of ultraviolet light is shown. Describe two ways that the graph is not constant with the values known for Denk plate. Now, for Denk plate, we have the work function. It's given. The work function here from previous one, the previous way, the work function, it's given. It's a 4.3 electron volt. From this work function, we can calculate F naught. We know that F equals HF naught, but we convert it to Joule, and we calculate F naught. So F naught equals phi over H. When you calculate F naught for the zinc, we can calculate it here. So 4.3 multiply 1.6 times 10 to the power negative 19. It is Joule divided by open bracket 6.63 times 10 to the power negative 34. Then the threshold is 1.03. So this is the threshold. 1.03 multiply 10 to the power 15. This answer is power 14, so it means 10.3. So it's 10.3 multiply 10 power 14 hertz. This is there from the graph. This is F naught. But F naught in the graph not equal 10.3 times 10 power 14. So this is one way. F naught from the graph, it is not F naught of the zinc plate. So number one, F naught from the graph is not the same as F naught of zinc plate. So this is one. Number two, when we calculate the slope of this graph. So when we calculate the slope of this graph or gradient, the slope, when you calculate it, it will be 2.1 multiply 10 to the power negative 33. It is not equal to H, Planck constant. H is 6.63 times 10 power negative 34. Then that two ways. So the graph is not correct for the zinc plate. Okay, so this question is a reasoning question about the zinc plate. Now, next part. Okay, next part. This is about hydrogen atom. He said, the diagram shows the energy level for an atom of hydrogen. An electron is in negative 13 ground state level of this atom. A photon interacts with this electron. Explain how this interaction causes emission of another photon. Now, electron moves to higher when that photon interact with electron. Electron moves to higher energy level, then drop back, releasing a photon. Again, we write this answer. Electron moves to a higher level, a higher energy level, then drop back, then drops back, then drops back, releasing a photon. So this is the answer of this part. Now, next the question. He said a photon has wavelength. So we have here lambda. So the given here is lambda. Lambda equals 218 nanometer. We convert to meter, so 218 times 10 power negative 9 meter. Determine the energy of this photon. Now we have lambda. So what is the energy? So the energy equals hc over lambda. H equals 6.63 times 10 to the power negative 34 multiply 3 times 10 to the power 8 divided by lambda 218 multiply 10 power negative 9. So this is the energy in joule. Okay, the answer is here 9.12 multiplied by 10 to the power negative 19 joule. To convert to electron volt divided by 1.6 times 10 power negative 19. So the answer in electron volt is 5.7 electron volt. This is the part BI. Now let us see the next part. Explain whether the atom of hydrogen could emit a photon with this energy. Difference between energy level are discrete. So there is no difference of 5.7 electron volts that we got. So not possible for this photon to be produced. Again, difference between energy levels are discrete. يعني point أرقام محددة discrete. Okay. No difference of this value اللي هو 5.7 electron volt. So not possible. So not possible for this photon to be produced. For this photon to be produced. Last part of hydrogen atom. Yes.
ايش معناته difference between energy levels are discrete؟
Here. Look. The photon emitted, if the difference between this one, يعني if you find the difference between negative 0.85 and negative 1, it is amount, fixed amount. Then photon emitted. But if the answer is not found between the difference, يعني for example, negative 0.85 minus negative 1.51, you will get this answer. Negative 0.85 minus plus 1.51. Then the answer is 0.66 electron volt. You will not get this value by the difference between any two levels from this. يعني if you find the difference between any two levels, you will not get 5.7 electron volt. Not found. So the photon cannot be emitted. This photon cannot be emitted because the difference between the levels, we cannot get this value from the difference between any two levels. Okay, Osama? If you make minus between any two levels, you will not get this value. Difference between energy levels are discrete, no difference of 5.7. So not possible for this photon to be produced. Now, let us see this question about spectrum. Spectrum can be produced by light from the sun. Discuss why black lines appear on this spectrum. Now, I write this in order. Number one. Okay, electrons. Okay, electrons absorb photons sunlight. From sunlight. This is part 1. Part 2. Electron moves to a higher energy level. Electron move to higher when absorbed. Higher energy level. Number 3, energy of photon equals E. This is absorbed, so E final minus E initial. E final minus E initial because it's absorbed. There are only a limit number of energy differences and only corresponding number of black lines. So these black lines according to this discrete energy. So number 4, there are only a limit or limited number of energy differences. And only corresponding number of black lines. So that appears as a black. Try to memorize this because this question is important about black lines. Now, last question about nuclear physics. Last topic. Now, look at this question.
يصير له صح
Yes.
تروح فوق ثانية عشان نقل.
I send this to you, Osama, don't worry, as a PDF file.
تمام.
Okay. Yeah. Now, try to solve the next question, please. This one. The incomplete number nuclear equation for one possible reaction that takes place. Try to solve this, please. Okay. Now, he said, state the name given to this type of nuclear reaction. This is a big nucleus bombarded by neutron, split into 2 smaller nuclei. This is fission. So the name is the fission. Fission is a big nucleus break down into small 2 nuclei. Fusion combine 2 small nuclei to be a big, to be more stable. Then this process is called fission. Complete the nuclear equation. Now, here we don't know what is the value of this. This is neutron. Then we have here, we can calculate, this is a neutron. So 92 plus 0, it's 92. And then 57 plus 42. Just I check, do we add electron or positron or whatever? Just to check, this is 92, the left side 92. The right side is 57 plus 42 equals 99. So the left side, so the left-hand side, 92 is less than 99. Then we add negative to this. Then this becomes negative. Then we have here negative. But we don't know how many negatives, how many beta particle. Then we say, let this beta particle denoted by X. Now we need to calculate X. So by using down, so 92 plus 0 equals 57 plus 42 plus 2 multiply 0 plus X multiply -1. From this, X equals -7. Then the equation is that we write the same equation. We write 2n01 minus 7. Okay, here x equals x equals 7, not minus 7, because we move x equal positive 7. Okay, because we move to the other side. Then this is plus 7 e negative 1 0. Then the value of x is 7. Okay, now next part. Okay, now next part of this question. The mass defect of reaction is U. Calculate the energy in joule. We know that 1 U, this is in the formula sheet, 1 U equals 1.66 times 10 to the power negative 27 kilogram. Now we need to convert this to joule. First of all, we calculate M. Okay, so the mass M equals 0. This is the mass defect delta M, 0.223 U. We convert U to kilogram, 0.223 multiply 1.66 times 10 power negative 27. The answer is 3.7 multiply 10 to the power negative 28 kilogram. We can calculate the energy delta M C squared. So 3.7 times 10 power negative 28 multiply bracket 3 times 10 power 8 whole squared. The answer is 3.33 multiply 10 to the power negative 11 joule. Suggest one form of energy released, kinetic energy of products. Kinetic energy of products. They move faster after the reaction. Okay, now. Okay, next question. Okay, now next question. Answer the following. Compare between gamma radiation, beta particles, and alpha particle in the table about the nature. Gamma is electromagnetic radiation. Electromagnetic radiation. Beta is negative or positive electron. Negative or positive electron. Alpha, helium nucleus. Now, charge of gamma, it has 0 charge. Beta is negative charge of electron or positive charge of electron. Alpha is double charge of electron. Now, next question. Calculate the binding energy. Now, to calculate the binding energy, we have to calculate how many protons, how many neutrons. For this one, so the protons equals 94, the neutrons equals 239 minus 94, so the neutrons equals 145. I said we need the binding energy. This is the nucleus, mass nucleus. Then delta M equals the mass of proton plus the mass of neutron minus the mass of nucleus itself. So equals proton here is 94 multiply for the proton it's 1.673 times 10 power negative 27 plus neutron it's 145 multiply 1.675 times 10 power negative 27 minus the mass of nucleus 3.9682659 multiply 10 power negative 25. When you calculate this, the answer is 3.31 multiply 10 to the power negative 27 kilogram. Then the binding energy equals delta M C squared. Delta M is 3.31 times the 10 power negative 27 multiply 3 times the 10 to the power 8 all squared. Then we can get the answer of this part. So the binding energy equals 2.98 multiplied by 10 to the power negative 10 joule. Now, last question of the exam is about half-life. Now, the activity, okay, when it is prepared, then this is given, this is activity. This is A note. It's okay? So this is A note. So given A note, the initial activity, 7.4 times the 10 power 7 BQ. Calculate the number of atoms in the sample 7 days later. 7 days, this is the time. So the time is 7 days. It's a good idea to correct, to convert, because BQ, it means per second. Then we have to convert it to second. 7 days, 7 multiply 24 multiply 3600. Now we can calculate this one, 7 days. Yeah, 7 multiply 24 multiply 3600. So as the answer, shift mode 73. So it is 6.05 multiply 10 to the power 5 seconds. Now, half-life, so this is lambda, sorry, this is T half. T half is 9.9 days. Okay. Also, we convert 9.9 days. So 9.9 times 24 times 3600 to convert to second, because at the beginning it's BQ. Then we have to convert all to second. So 9.9 multiply 24 multiply 3600. So the answer is 8.55 times 10 to the power 5 seconds. Now, first of all, we calculate lambda. Yes.
متى يعني يحتاج نحول لسكند ومتى ما يحتاج؟
لو هو مديني هنا الاكتيفيتي ان بي كيو، يبقى ملزمني بير سكند في البدايه.
يعني تو اذا ما اعطاني بي
يعني
كيو،
مثلا لو كان بيتكلم على النمبر اوف اتومز بس، ماشي؟
ايوه
خلاص، يبقى ما نحول.
يعني اذا اعطاني نمبر ما يحتاج.
لو كان النمبر اوف اتومز وقال لك سؤال دايركت او كان اوكي، لكن في هذا السؤال لازم نحول كله الى سكند يكون افضل.
اوكي
خلاص. لامدا equals ln 2 divided by t half. So ln 2 divided by t half, it's 8.55 times 10 power 5. So ln 2 divided by the answer. So it's 8.10 times 10 power negative 7 per second. Now we need here n note. We need n. Okay, he said calculate the number n. Now, what is n naught? We have a formula related to lambda. It's okay. So A naught equals the lambda n naught. Okay. Then we can get n naught from this formula. So n naught equals A naught divided by lambda. A naught is given 7.4 times the 10 power 7 divided by lambda 8.10 times the 10 power negative 7. We can calculate this. So 7.4 multiply 10 to the power of 7 divided by the answer. The answer is 9.13 multiply 10 power 13. Now we need to calculate n. How to get n? The formula that n equals n naught e power negative lambda t. Then n equals 9.13 times 10 power 13 e power negative lambda. Lambda is 8.10 times 10 power negative 7. T here, we calculate t at this, okay? At this 7 days. So this is the time, okay? Which is 6.05 multiply 10 power 5. This is the time. Now we calculate this. So 9.13 multiply shift length negative 8.10 multiply 10 to the power of negative 7 multiply 6.05 multiply 10 to the power of 5, press equal. So the answer is 5.59 multiply 10 to the power 13 nuclear. Now we go back to the multiple choice. So let us go back to multiple choice. I give you the answers, and if you have any doubt, just send me in WhatsApp. Okay, yeah. Actually, I brought some difficult questions in multiple choice. The first question is easy. It's direct. If you solve it, it's easy. He said, well, find the amplitude and the wavelength. Here, the graph shows variation of time displacement of an electromagnetic. Electromagnetic, it means the speed is 3 times 10 power 8. This is time. So we need the wavelength. Okay, C equals lambda F. So lambda equals C over F. We find the time period and then we find the frequency. Then the answer of this part is the first when you solve. So this is applying a question. Next question. The diagram, okay, here shows displacement versus with distance along stationary waves. Which of the following statement is not correct? Actually, the not correct, Y and Z have the same amplitude. This is wrong. Y and Z have, okay, this is not correct. So Y and Z have different amplitudes. So this is not correct. Now, next. Okay. This is about polarization. Take care. Okay, he said, okay, just a little. Ray of unpolarized light is incident on a polarizing filter. It's one filter, not two. Not two. It's okay. It's just one. It's okay. Again, I write. It's one only. The polarizing filter transmitted light of intensity I. So this is I. The polarizing filter is then rotated in direction shown. Its direction. On the diagram, which of the following gives intensity of light when it's rotated 90? Actually does not affect by rotation because it is just one filter. It's affected if the difference between the two filters is 90. Then it will be 0. So 0 if two filters. If two filters. But because it's one filter, it stays the same. Does not affect. Because it is single filter. So the rotation does not affect. Now, number 4, the arrangement increasing frequency. This is easy question, but you have to memorize it, by the way. Take care. This is very important question about electromagnetic waves. Now, number 5, this is about diffraction grating. Okay, which one maximum order? I give you the answer for this one. Okay, just a minute. This one here. Lambda equals lambda proportional to D. Then decreasing the wavelength, decreasing D. So it's direct, and D is the correct answer here. Now, next question. Which of the following statement about wave is correct? Of course, polarizing is only transverse, can polarize. Longitudinal cannot be polarized. Next. This question is important. A question of actually, this is about here. Number 7, I will give you here. Fn equals 2n minus 1 multiply the speed of sound is 340 over 4L 0.85. The answer will be 100 multiply 2n minus 1. This value must be odd. 2n minus 1 must be 1, 3, 5, 7, 9, and so on. Then the answer is 100 or 300 or 500 or 700 or 900. Cannot be 200. Not reduced. Must be odd. Now, this question is important. Now, next, the diagram here. It said possible jump. It is just here 3. You have 3 jumps from n equals 3 to 2, n equals 3 to 1, n equals 2 to 1. Just 3 jumps. Now, next. Ultraviolet, this one, it is important. The correct answer here is part B only. Try to think of this. If you have any doubt, I can. Now, this question also, it's a blind, but it's a little hard about this. So here, the charge of electron, 1.6 times the 10 power negative 19. The mass of electron, 9.11 times the 10 power negative 31. We can calculate lambda, it's h over mv, or h over square root of 2m kinetic energy. From this, kinetic energy equals E times V. E is the charge of electron, and V is potential difference 150. So we can calculate V, so we can get lambda. Lambda by calculation, it will be 1 times the 10, 1 times the 10 to the power negative 10 meter, which is 0.1 nanometer. So it is 0.1 nanometer. So the correct answer is that. Now, next question. Okay, here, this is regarding to alpha scattering. Penetration of matter by radiation depends on ionizing the power. Alpha particles are highly ionizing, so the correct answer is B. And also number 12 is important. Okay, this number 12. It said the graph shows binding energy per nucleon. So this is about the stability. Depends upon nucleon number or range of which of the following can deduce from the Fe reading undergoes fission. Of course, this is not correct because it's stable. Just here, we can say the correct answer, low mass nuclei release energy during fusion. Fusion, small mass combined together. Fission, big one split into two smaller ones. Now, next question. Which statement about alpha particle scattering here? A tiny proportion of alpha particle are deflected through large angle. Yeah, this is correct because this is about Rutherford scattering. And the last question is about T half. So remember, from the graph, we can deduce T half. So T half equals 20 seconds. We can get lambda is ln 2 over 20. Then we can get A equals A naught E bar negative lambda T. When you use this formula, you will get the answer here. This is the answer. Okay? Now, I hope this will be useful for you. I advise you to solve this exam again and solve the last year 34 first session and second session. And then the exam will be easy, inshallah, tomorrow because it is the last exam and you are tired. I hope it will be easier than this exam, inshallah. Okay, شباب؟ يلا حياكم الله وبالتوفيق إن شاء الله. يلا السلام عليكم.
شكرا أستاذ.
يلا أستاذ، شكرا
العفو.
جزيلا،
العفو.
جزاك الله خير.
عفوا. الله يخليك حبيبي، مع السلامة.
مع السلامة.